Hello. Hello.
Yes, ma'am.
Hi, Kirti ma'am.
Yes, ma'am.
Hello, ma'am.
Uh, I hope I'm audible, right?
Yes, ma'am.
So, sir, shall I
Yes,
start?
ma'am. Yes, ma'am. Yes, ma'am.
Fine. Thank you. Very good evening, everyone. Today is yes. Good evening, Mukesh sir. So, I think today is the day 3, and according to the agenda, today I'm going to discuss ANOVA. So, on the first day, I think I discussed the descriptive statistics. Along with that, I discussed the chi-square test, right? And then second day, I discussed the t-test, varieties of t-test. Yes?
जी मैडम.
Right. So can any one of you tell me what do you understand by term descriptive statistics?
Statistics which are used to describe something. We can get the features of that.
Very correct. Very correct. Means to summarize the data or to get the summary of the data so that we can understand the nature of the data, we are using descriptive statistics. And what are the methods of descriptive statistics?
T-test, F-test.
Hello, this is Dr. Neeta Deshpande.
Hi, ma'am.
Measures of central tendency, ma'am, measures of distribution, and measures of dispersion. In the
Right.
measures of central tendency, mean, mode, and median, and measures of distribution, skewness, and Curtis, I think,
Courtesy.
pronunciation, I mean, Curtis, okay, and measures of dispersion, SD, and variance.
Very correct. So Nita ma'am said correctly, we are using the measures of central tendency, measures of dispersion, measures of distribution to summarize the data. That is mean, median, mode, standard deviation, variance, and kurtosis and skewness. Right. Then I talked about non-parametric and parametric test. I have explained you the concept of both the tests. And then in the category of non-parametric, we have already discussed chi-square test. And we have seen the two variants of the chi-square test, that is the goodness of fit and the independence of attributes. Further, I talked about parametric test. In that category, we have seen the t-test and the variety of t-test, that is 1 sample and 2 samples. Right? Today, in the same sequence, I'll proceed with the next test, that is the ANOVA test. Fine?
Yes, ma'am.
Yeah. I have shared the Excel sheet for this purpose on the WhatsApp group. I hope you will have received that, you have found that particular Excel sheet. If yes, I request you to please download so that you can work along with me on that. Fine? Fine?
Yes, ma'am.
Yes. Means you people have received, when you are saying yes, I am assuming this thing, you people have received that sheet. Fine. So I'm sharing my screen. And I want a confirmation from your side whether my Excel sheet is visible to everyone or not.
Yes, it is, ma'am.
Visible?
I'm not visible.
Visible madam.
Visible. Right. So, sir, if it is not visible, you need to check whether you have pinned my screen or not. You need to pin my screen. Right? So, shall I start?
Yes, ma'am.
Yes, ma'am.
So, I'll talk about firstly the ANOVA. ANOVA stands for anyone?
Analysis of variance.
Variance.
Very correct. Analysis of variance is known as ANOVA. That means we want to see the variance or the difference in the mean. Generally, it is the extension of independent samples t-test. So, what is independent samples t-test?
Whether the difference between two independent samples is significant. Mean difference is significant or not.
Very correct. Very correct, sir. Sir said very correctly. We are looking for the significant mean difference of the continuous variable in the two groups or two samples or two categories of the independent variable. right? That is known as the t-test or the independent samples t-test. But I think we know it is not like that always there will be the two categories or two samples or two groups. Might be it is possible there can be more than two groups or samples, right? So in such case, the limitation of independent samples t-test is that it cannot deal with more than two categories or more than two samples or more than two groups. In such case, we need to take the help of ANOVA. So ANOVA is known as the extension of independent samples t-test. Wherever we are having more than two categories or more than two groups in the independent variable, in that case, we are using ANOVA instead of using the t-test. So if suppose you are having more than two categories in any independent variable or in any categorical variable, and you want to perform t-test, so you need to priorly decide in which two categories you want to make comparison. Is it clear, the difference?
Yes, ma'am.
Yes. So can any one of you tell me what was the variable requirement in case of independent samples t-test?
Ma'am, two measures should be given, two elements like height and weight.
Okay. Fine. Anyone else? Anyone
Ma'am,
else attempt?
two independent samples will be given taken as like male and female.
Okay, fine. Any other attempt? Yes. If you can recall independent samples t-test, where we are requiring the two variables, one continuous and one categorical with two categories or two groups, right?
Yes, ma'am.
Right. So same number of variables are also requiring in case of ANOVA, except in the independent variable, where in case of t-test, there we need only two groups. Here we need to have more than two groups, right? So you can write one continuous scale variable and second is one categorical variable with more than two groups or categories or samples. Fine. Fine.
Ji, madam.
Right. So this is the only difference between t-test and ANOVA. That means in ANOVA, we also need to have one continuous variable, which is also requirement of the independent samples t-test. And we also need to have one categorical variable in both the cases. But the difference is in categorical variable, in case of t-test, we need to have only two groups. In case of ANOVA, we need to have more than two groups. Fine?
Ji, madam.
Fine. Now, so hypothesis format will also be same, which I already discussed in case of independent samples t-test. That is, there is no significant difference in the continuous variable corresponding to the categories of the independent variable, right? Now, there is a types or variety in the ANOVA. So, usually it is
Two types
one way
and two way.
ANOVA and there is
Two way.
two-way ANOVA. Right? In the two-way ANOVA, further again we are having the two classifications, that is with replication and without replication. Fine?
Ji, madam.
Fine. So, one-way ANOVA, meaning we need to have one dependent and one independent variable. But in case of two-way ANOVA, we will be having only one dependent and two independent variables. Right? Clear to everyone?
Ma'am, in one way, it will be one independent and one dependent. In two way, it will be one dependent and two independent.
Yes.
Two independent.
Correct, ma'am. Okay, ma'am. Okay.
जी मैडम.
And whenever you are saying dependent, that means continuous scale variable, and whenever you are saying independent, that is categorical variable, right? Fine, everyone?
Ma'am, repeat again.
Whenever you are saying dependent variable, meaning continuous variable, independent variable meaning is categorical variable.
Okay, madam. Okay.
Fine. So it is fine. May I proceed further?
Yes, ma'am.
Yes, ma'am.
Now, for example, you can see the data which I have shared with you. I have opened the very first sheet with the name one way. So you need to identify the sheet name. One way will be written in the tab sheet name, and you need to see that sheet and open that, right? Where you can find. I hope everyone has located the sheet like mine. May I start explaining you this?
Yes, ma'am.
Yes, ma'am.
Fine. You can see here we are having a strength of tapes. So here we are getting the supply of the tape from the three suppliers, supplier 1, 2, and 3. And these are the strengths of the tapes received from the different suppliers, right? So you need to find here how many variables are given. So we are having the two variables here. First one is the strength of the tapes, which is a continuous variable. You can find this is the strength given of the tape. So these are the or we can say this is the dependent variable or the continuous scale variable. Second variable is the type of supplier, that is supplier 1, supplier 2, supplier 3. So this will be your categorical variable, and categories will be 3. Supplier 1 is one category, supplier 2 second category, supplier 3 is third category. Is it clear?
जी madam.
Now we will formulate our hypothesis here. Firstly, to perform one-way ANOVA, so you need to write down the hypothesis. That is, there is no significant difference in the mean strength of tape on the basis of type of suppliers, right? Hypothesis is clear?
Ma'am, I want to ask one thing. Maybe it may sound very simple question or stupid question. Ma'am, how do we make this hypothesis? Like, on what basis should I generate the hypothesis?
Ma'am, if from the research point of view, you are asking to me. So always
ma'am.
we are having the defined objectives, right? From the objectives, we need to identify firstly what is the purpose in the objective and what are the variables available. Accordingly, you will formulate your hypothesis. Usually, this
Okay.
is the way in the research. But if suppose I have given you directly the data, right?
Mhm.
And I am expecting you to find whether the mean strength is different from the suppliers or according to the suppliers or not. So that means you need to check, sorry, how many variables are there. Firstly, we can see this thing. One variable is strength is there. Second is the suppliers variety is given here. Supplier 1, 2, and 3. Right. And when we are saying whether the strength is same of the tape which we are receiving from the different suppliers, that means we want to see that whether the strength or the mean strength of the tapes is same from all the suppliers or than 0.05. So again, we do not accept the null hypothesis, right? Or we do not have the sufficient evidences to reject, to accept the null hypothesis. Fine?
Ma'am,
Yes.
ma'am, can you show the Excel which we are working on?
Sorry, ma'am.
From the Excel on which you were working, it's not visible right now.
Just a minute. Okay, it's visible now.
Ma'am, in this, this F calculation is more than F critic. So, ma'am, if it is equal, for example, any day, then,
Sorry?
ma'am, if this as F calculated, F is more than F crit, so we have not accepted the null hypothesis. If in A it is equal to F crit, then can we accept?
No, even in that case also we will not accept.
So every time, ma'am, F crit should be more.
No, it can be less than also, no? F
To
also
accept, ma'am,
be less than to a critical also. So it is generally less than or equals to. Generally equals to we are keeping here.
Then we can accept the null hypothesis.
Do not reject.
Do not reject.
Meaning is same. We are accepting that.
Yes, ma'am. That's what I wanted to know. P value is less than 105. 9.9. Ma'am, how is it less than 105, ma'am? P value.
This is 10 to the power minus 6. E minus 6 meaning is 10 to the power minus 6.
Okay.
So 10 to the power minus 6 is a very small figure.
Yes, ma'am.
So we can say, yes, so we can say P value is less than 0.05. So we do not accept the null hypothesis, right? Is it clear?
Ma'am,
yes.
In this both condition, if any one condition is more than this, P value is more than 0.05, but F calculation is...
It is not possible, ma'am. Only P value we are deriving using these things only. So it is not possible. Both the values of both, in both the cases, the results or the decision will be same.
Okay, ma'am.
Right. So if we are not accepting the null hypothesis, what we can conclude? We can conclude that there is a significant difference in the mean strength of the tapes on the basis of the type of suppliers. Right? Means if I will compare the various tape strength which we are receiving from the various suppliers, I can say that the tape strength is different. Right? Fine, everyone?
Yes, ma'am.
Okay, so this way, this is known as one-way ANOVA that we have seen using the Excel. Next sheet is for the practice purpose of one-way ANOVA, so that you can use for your purpose. I'll come to the next sheet, which is named as with replication. I hope everyone has found the third sheet. Open third sheet. May I start explaining? Any confirmations?
Yes, ma'am. Open up.
Okay. So we will see firstly the meaning of replication here, and then we will, as you can firstly see how many variables are given. So we are having total how many variables? Can anyone attempt?
2.
Which 2 variables, ma'am?
Ma'am, type 1, type 2. Strength ka.
Okay.
Box type 1, box type 2. The second one is the tape supplier 1, 2, and 3. They are continuous variable.
Okay. Fine. Okay. Anyone else? How many variables we are having in here?
3 variables, na ma'am? 3 variables.
Can you name them, ma'am?
Strength of tape, then box type is there, and suppliers.
Very correct.
Continuous.
Very correct. Sudha, ma'am, right?
Deshpande, madam.
This Pandey. Okay, fine. Thank you, ma'am. It's very correct. Ma'am said correctly. We are having three variables. First one is the box type, that is type 1, type 2. Second one is the type of the supplier, supplier 1, supplier 2, supplier 3, and the strength of the tapes. Right? So we are having total three variables. So we can say that tape strength tape is the continuous variable, but remaining two variables are the independent variable or categorical variable. Is it okay?
Yes, ma'am.
So what we want to see here, we want to see here the significant mean difference in the tape, right? Tape is strength according to the box type and according to the tape supplier or the type of supplier, right? Firstly, you need to see that the meaning of replication. What is the meaning of replication? So as you can see, we are having two categorical variable or independent variable. One variable we have taken in the column, that is supplier 1, 2, and 3. Second, we have taken in the row, that is box type. So whatever variable, whatever categorical variable we are taking in the row, there we are using the replication concept. Means in the box type, only two categories are there, type 1 and type 2 box type, right? So I am replicating this type 1, right? And you need to see, I'm selecting this till wherever it is repeated till here, right? Now, just a minute. You can see the count is coming as 15, right? So total 15 times I have repeated the type 1. Or means there is a box of type 1, in that there will be certain tapes will be there. So 15 tapes we have picked and we have taken their strength from the supplier 1, similarly 2 and 3. Is it clear?
Yes, ma'am.
Then come down and select the type 2 and see this will also be in the same number, that is 15. If these two will not be in the same number, we cannot perform two-way ANOVA. So that way, this variable which you are taking in the row as a categorical variable, there should be the equal replication, right? So type 1 is repeated 15 times, type 2 is also repeated 15 times. Means box type 2 we have taken, and from that box we have taken the 15 tapes and we have noted down their strengths for all the three suppliers. Is it clear?
Yes, ma'am.
Yes, ma'am.
Right. Now you need to perform that means now what is the main thing you need to see here, whether the tape strength is same according to the box type and according to the supplier or not. So that way we need to create more than one hypothesis here. I think in case of this replication, you need to create total 3 hypotheses. I'm writing here. I think requirement I do not need to write, right? I have already told you that thing in the case of one-way ANOVA. Generally, in case of two-way ANOVA, we need to have 3 variables, two categorical and 1 continuous. That we have seen in the example also. Now I am talking about the hypothesis. So your first hypothesis will be
There is no.
Hmm.
Can I try, ma'am?
Yes, definitely, ma'am.
But there is no significant difference in the mean of the box types with respect to suppliers. No, no difference in the mean of suppliers.
Okay, I think I have written. You can check.
Strength of tapes, with respect to strength of tapes with respect to type of suppliers.
Right.
Okay.
Then type of boxes, right?
Yes, ma'am. Was 1, 2.
And one
And
more possibility is there. That
There
is
is a H1. There is no difference in the mean strength of tapes. Boxes, suppliers of types. Boxes count, tapes count.
Means when we are considering both the variables simultaneously, this is the individual effect we are looking. Whether the supplier, if we are changing the supplier, whether it is impacting the tape strength or not. When we are changing the box, when we are changing the box where we are, whether we are able to observe the difference in the strengths or not. These two are the individual impacts we are looking, right? Now here we are combinedly looking. Suppose from supplier one, if I am taking box one, so whether the strength is different, or when I'm taking the box of type 2 from the same supplier, so the strength type will be different of the tapes. This is the meaning of the third one. So we want to see the combination, and then we want to see whether this combination is impacting the mean strength of the tapes or not, right?
Yes, ma'am.
Yes, ma'am.
Yes.
So now I think I have explained you the basic thing that you need to have the same replications, whatever number of categories you are having in your row variable, that you need to see. And then if it is fulfilling your criteria, and that way you can go for the performing of the two-way ANOVA, right? So you can now go to the data tab, click on the data analysis toolpath, and then select ANOVA two-factor with replication. Fine.
मैम
Yes.
विदाउट रिप्लिकेशन क्यों नहीं?
I think I'll explain that in the next slot, sir. I think you can find the sheet is already there.
ओके मैम.
So I need to tell you what is without replication.
ओके मैम.
Click on the OK button. Now you need to select your entire data. Then
जी मैडम.
come to the rows per sample. So you need to see whatever the categorical variable you have taken in the row, in that how many replications per category is there. So I have already seen, I already explained, when I selected the range, we have seen type 1 was replicated or repeated 15 times. Similarly, type 2 was repeated 15 times. So you need to write here 1, 5, 15. So it is depending how many times you are repeating. Suppose male and female is one category. On the basis of gender, we want to compare something, right? Is it clear?
Ma'am.
Right? So you can say 15 males data I have collected, or 15 females data I have collected, or 20 or 20. It can be any number, but number should be same, right? So that way you can see this thing. So you need to count how many times the replication is being done by you, or you have collected the data like that, and accordingly you need to write this. So this should be the same number for all the categories of the categorical variable which you are taking in the row. There can be more than 2 categories also possible. It is not like always 2 categories, more than 2 is also possible. Okay?
जी मैडम.
Level of significance is 5%. Now output options, you need to select the option wherever you want to generate your output. I selected the first one, and I am selecting this blank cell. And I think we are all set to get the output. You can click on OK now. So I hope I can click on OK. Everyone has followed the same thing which I explained. May I click on OK?
Ma'am, excuse me. After pressing output range, then what you did, ma'am?
I come to this box. I have kept my cursor here and selected a blank cell.
Okay, okay, okay.
Fine.
जी मैडम.
So you need to click on OK to get the output. I hope I can explain you now this.
Yes.
Yeah. You can see first table is again a summary table for type 1 box and type 2 box. So in type 1 box, you can find supplier 1, supplier 2, supplier 3. From all the 3 suppliers, we are receiving, or we are generally testing the 15 tapes, right? So count is 15, 15, 15. Some of the strength for all the 3 suppliers of the tape is this. This is the average strength or average strength of the tapes. This is the variance in the strength of the tape, right? So this is for type 1 box, this is for type 2 box. And when you will combine both, means combinedly, if I'm looking for only the, combinedly I'm looking for type 1 and type 2 both, you can find the total is given here. These are the figures given here. Then come down, see the main table, which is the ANOVA table. There you can find, we are having the source of variation. There you can find sample, columns, interaction, and within. Sample meaning is the row variable, that is the box variable, right? Column means the supplier type, and the interaction means when we are combining both, right? So sum of squares, degrees of freedom, mean sum of square, F value, P value, and critical value. So we need to look at these three things or only the P value. Up to us on what basis we want to make a decision. So if I will look at the P value, I think all the P values are less than 0.05. That means our data is stating us we do not need to accept any of the null hypothesis, right? Because all the P values are less than 0.05. Is it right? Right. Similarly, if you will compare your calculated value from the critical value, all the calculated
Excuse me,
values
ma'am.
are,
मैम यहाँ पे P वैल्यू जो है
yes,
हेलो
yes.
जी मैम यहाँ पे P वैल्यू है इसमें E दे रखा है 3.6 E. What do you mean by E?
I think, sir, previously also a ma'am asked the same question and I said it is nothing but it is 10 to the power minus 10.
Okay, madam. Okay, okay.
So all the P values are less than 0.05. Similarly, if I will look at the calculated value, all the calculated values of the F are greater than the critical value. So that means again, the same conclusion we are drawing here, that we are not going to accept the null hypothesis. That way, what we can conclude? We can conclude this thing, that there is a significant difference in the mean strength of the tapes with respect to the type of suppliers. That means from all the three suppliers, whatever tapes we are receiving, the mean strength is different. Similarly, whatever the boxes we are receiving, that is box type 1 and box type 2. If we will consider only the box type also, so according to the box type also, the strength of the tapes is different. Then when we are comparing, means when we are combining both the categorical variable, means suppose I'm picking the box type 1 for the supplier 1 or box type 1 for the supplier 2. In that case also you can see we are finding that there is a significant mean difference in the strength of the tapes, or you can say it is because of the interaction effect of the type of supplier and the box. Clear?
Yes, ma'am.
Yeah,
Fine.
madam.
So this was the two-way ANOVA with replication case. Now we will go for the sheet number 5. Sheet number 4 is for the practice purpose of the with replication case. So I suggest you to go to the sheet number 5 without replication case. Replication case.
सॉरी मैम मैम जस्ट वो एक्सेल एक बार दिखा देंगे जो अभी आप रेप्लिकेशन वाले पर हो, जस्ट एक बार स्टडी करना था मैम वो पी वाला. हाँ यस यस F calculated is lesser than is greater than F critical
मुझे तो दिखा था वीडियो में कर लीजिए आप.
is
Yes.
not accepted.
So null hypothesis is not accepted.
Yes ma'am, got it.
Yeah. Now we will go to the without replication case. There you can read the condition is given in the sheet. You can read it. Our situation says a new fertilizer has been developed to increase the yields on the crops, and the makers of the fertilizer want to better understand which of the three formulations, that is blends, of the fertilizer are most effective for wheat, corn, soya beans, and rice. They test each of the three blends on one sample of each of the 4 types of crops. The crop yields for the 12 combinations are shown in the table. You can find we are having 4 different variety of the crops: wheat, corn, soya, and rice. and we are having 3 blends or 3 formulation of the fertilizers, blend X, Y, and Z, right? Now you can see in the previous case, when I was talking about the replication case, whatever variable we were taking on the row, that was repeated multiple times, right? But here, whatever variable we are taking, and that is the categorical variable we are taking in the row, it is not replicated. It is coming only once. So this is a case of without replication, right? Clear, everyone?
जी मैडम जी.
Now you can find that we are having the 3 variables. First one is the type of crop, second one is the type of blend, and third one is the yield of crop, which is this, right? Now I want to see whether there is a significant difference in the yield of crop on the basis of the type of crop and on the basis of blend of fertilizer, right? Is it okay?
Yes, ma'am.
So we will make only 2 hypotheses in case of without replication. In case of without replication, if we are not replicating these categories, that way there is no use of interaction, right? Interaction will be possible only when you are using or replicating the one of the variables categories. Means one of the variables means either the blend. So whatever variables we are taking in a row, only that is possible to replicate here, right? So that way you can see it is not possible here to replicate, or means the data is not given in the replication form. That is why we cannot find here the interaction thing. So only 2 hypotheses will be formulated, one for the type of crop, second is for the type of fertilizer, and then you are interested to see the significant mean difference in the yield of crop. Is it okay?
Ma'am, ma'am, I want to try to make the hypothesis.
Yeah, definitely. Please, ma'am.
गलत होगा तो sorry.
No problem, ma'am. I think this is the learning platform, and we all are learning from each other. No problem. Please attempt.
मैम वो Excel दिखाइए ना. Interesting है मैम. Ma'am, first hypothesis can be there is no significant difference in the yield of crop with respect to blends.
With respect to
Change in blend,
okay,
or there is no significant difference in the mean of crops with respect to the type of crops.
very correct. Means you can say there is no significant difference in the mean yield of crop on the basis of type of crop and on the basis of type of blend, right?
Right again.
Correct, very correct. Good attempt. So now we will see how to perform without replication case using Excel. So what you need to do, you need to go on the same data tab and you need to locate data analysis. There you will select the third option, ANOVA 2-factor without replication. I hope it is easier to locate this, right? May I click on OK?
Yes, ma'am.
So click on OK. Here you need to give the range of your data. In this particular step, you will provide the range of your data. You will select the labels if you are selecting your data, including the labels. Level of significance 5% by default. Output range up to you, wherever you want to generate your output. I'm generating in the same sheet. I think I'm all set to get the output. So I hope everyone has done the similar kind of things. May I click on OK?
Yes, ma'am.
Fine. So I think you all can see 2-factor without replication case. Summary table says according to the blend and according to the weight. In the blend, you can find we are having total, if I talk about blend 1, total observations are 4, for second blend 4, 4, 4. Similarly, for the crop 3, 3, 3 and 3, right? So you can find here for blend X, we are having total observations 4, for Y and Z also 4 and 4. This is the yield of crop, total yield of crop for crop when we are talking about the blend X. From the blend Y, total yield of crop is 617, and likewise for the blend Z. This is the average crop for all the 3 blends and this is the variance in the crop for all the 3 blends. Talking about the type of the crop, these are the number of observations given per crop. This is the sum of the wheat, means sum of the yield of the crop, or that is sum of the yield of the wheat here, right? This is the total yield of wheat, total yield of corn, soya, and rice. Similarly, this is the average yield of wheat, corn, soya, and rice. This is the variance in the yield of wheat, corn, and soya, and rice, right? So this is the summary table. Coming down, talking about the next and the main table, which is talking about the ANOVA table. Source of variations, you can find only 3 are there: row, column, and error. So row means, in the row we have taken the blends, and in the column we have taken the type of crop, right? So you need to see the p values here. If I say row, so the p value is less than 0.05. That means there is a significant difference in the mean yield of crop on the basis of blends, right? But when I look at the p value for the column, it is greater than 0.05. That means I can say there is no significant difference in the mean yield of the crop on the basis of type of crop. Means if I will consider type of crop, mean yield of crop is coming almost similar. But when I talk about which type of blend I am using, so I can say this thing, according to that there is a significant difference in the mean yield of crop. Fine?
Yes, ma'am.
Yes, madam.
Yes. Similarly, if you want to make your decision on the basis of calculated and critical value, you can also find here calculated value of f is greater than here in context to the critical value. That means you can compare these two. So we are not accepting the null hypothesis here. This is here, but in case of second case is different. Here your critical value is greater than to your calculated value. So the case is different here or opposite here. So here in this case, you need to accept your null hypothesis. That means you are concluding there is no significant difference in the mean yield of crop for the or the variety of the crop or the type of the crop, right? Fine,
ma'am.
everything? Right. So I think this is all from my side. Next sheet is for you for practice purpose. So I will only summarize today's session and then I'll take the questions if you are having any. So on the last or the concluding remark of this session, I can say this thing. Today I talked about the ANOVA, where we are saying this thing that it is nothing but it is an extension of the independent sample status. The number of variable, if I talk about one-way ANOVA, requirement